An ongoing quest for advancement in technology. A never-ending saga of quality pursuit. An insatiable zeal towards perfection and a penchant for meeting commitments and client satisfaction. These principles hold the key to success of AFCONs and have catapulted us to new glitzy heights.
And you're ready to flow.
Established in the year 1959, AFCONs today is one of India's premier construction companies, involved in infrastructure development segment with an enviable record of executing varied types of construction projects in the fields of bridges, roads, marine works, pipelines, tunnels, LNG tanks, nuclear power projects, specialized foundations and superstructures. In every phenomena, the beginning is always the most important event. The success saga of AFCONs also goes back to the year 1959, when it was established as a partnership firm between Rodeo Foundation Engineering Limited, Switzerland and Hazrat & Company, India. The company started its operations with construction of specialized foundation activities. Year 1963 saw the first major diversification landmark of the company as it entered the field of marine constructions. The company completed 140 marine structures in the years to follow, including building dock complex at Vizag for Hindustan Shipyards, coal handling berth at Ennore for Chennai Port Trust, crude unloading jetty and associated facilities at Nagapattinam in Tamil Nadu for Chennai Petroleum Corporation, LNG jetty at Dahej for Ballast Nedam International, and marine oil terminal berth J1 and J2 at Mumbai for Mumbai Port Trust. In 1976, the company was registered as Asia Foundations and Constructions Limited, AFCONs. AFCONs entered in road construction in the year 1986 and executed more than 600 kilometers of roadworks and expressway projects in India. National Highway 1 in Punjab, total length 288 lane kilometers. National Highway 45 in Tamil Nadu, total length of 160 lane kilometers. East Coast Road in Tamil Nadu, total length of 108 lane kilometers. State Highway Project in Andhra Pradesh, total length of 320 lane kilometers. Panagarh Moregram Road in West Bengal, total length of 432 lane kilometers. For some of the key road projects executed by the company till date. Some of AFCON's major strengths have been construction of road and railway bridges, flyovers, viaducts on pile foundations, well foundations and open foundations, and bridge superstructures comprising of pre-stressed concrete box girders. Some of the bridges and flyovers constructed by AFCONs have been awarded the most outstanding bridge structures, which include Thane Creek Bridge for MTP Railway, first prize for the best concrete structure in India in 1991 by American Concrete Institute, Maharashtra chapter. Sharavati Bridge for Konkan Railway Corporation Limited, second prize for the best superstructure and pre-stressed concrete work in 1994 by Indian Institute of Bridge Engineers. Mandovi Bridge for Konkan Railway Corporation Limited, third prize for the best superstructure by Indian Institute of Bridge Engineers in 1994-95. Road bridge across Thane Creek at Airoli, Navi Mumbai for Sidco MSRDC Limited, first prize Category 1, superstructure in pre-stressed concrete in 1998 by Indian Institute of Bridge Engineers. The year 1996 saw the company change its identity to AFCONs Infrastructure Limited due to its field of operations being closely related to infrastructure development. From the year 2000, AFCONs is part of the $500 million Sharpurji Palonji Group and is one of the market leaders in construction industry. Besides doing major projects in India, AFCONs is also involved in various marine works in Sri Lanka, Mauritius and Yemen, railway bridges and marine facilities in Iraq, marine work in Assab and Ethiopia, and desalination plants in Oman. With a visionary management supported with able manpower and state-of-the-art equipment resources, The turnover of the company has seen a growth of over 100% over the last 5 years, from a mere 310 crores in the year 2000 to 700 crore rupees in 2005-2006. Afcons today employs more than 5,000 dedicated personnel, which include 1,000 engineering and management personnel, 1,500 technical and skill operators, and over 2,000 people as project staff across its project locations. The success of Afcons is evident by its most reputed clientele. The never-ending and growing list of the most reputed names in different industries relying on Afcons reflects the fact that Afcons have not just ruled the market, but have also won hearts and trust of our customers spread across the globe. To honor our time frames, delivery schedules, and quality parameters, we work with the best technology, systems, processes, and equipments that help us cut down on delivery cycle. Professionally managed, technology-driven, with a belief that ideas and innovations with the right action always bring in the desired growth, Afcons is roaring to capture diverse frontiers and affix achievements into our success saga. Every milestone achieved at Afcons creates another milestone, so that the journey to attain utmost customer satisfaction doesn't end, so that every inch of our output keeps getting more and more perfect. In the year 2004, Afcons was awarded the contract for design and construction of special railway bridge over the river Chenab. Chenab Bridge is a steel arch bridge that spans the valley of the river Chenab near Jammu in northern India. As a part of Udhampur-Srinagar-Baramulla Rail Link project, this bridge will connect the Katra and Laol section of Jammu and Kashmir state. This major EPC contract, valued at 512 crore rupees, happens to be the single largest bridge contract awarded by the Indian Railways till date. With a total length of more than 1.3 kilometers, supported at 360 meters above the riverbed level, this bridge will be the highest steel bridge in the world. The contractor for this project is CBPU, that is Chenab Bridge Project Undertaking, which is an Afcons Ultra joint venture. Konkan Railway Corporation Limited, or KRCL, is the client for this project, whereas owner of the project is Indian Railways. The project is designed by WSP Cortes Limited of Finland, along with LAP Germany. Force Technology is the agency to carry out the entire wind tunnel tests in Denmark, whereas Scott Wilson Kirkpatrick Limited UK is the proof checking agency. The Chenab Bridge alignment passes through a very rugged terrain of the Himalayan range and crosses the deep gorge of the river Chenab. The remote area location for the project without any road and communication facilities posed a real challenge for the construction process to start. The motorable road existed up to village Kanthan, which is 105 kilometers from Jammu, and one had to travel about 15 kilometers on foot from Kanthan to reach the bridge location. The two important villages on left and right abutment of the bridge are Bakkal and Kauri respectively, and are accessible by foot only. Therefore, constructing the railway bridge at this difficult terrain involved a significant engineering challenge. To mobilize the construction equipment at the project site, an access road of about 14 kilometers was constructed up to Kauri from Kanthan, whereas access road to Bakkal village was made from Salal, which involved construction of a tunnel about 0.1 kilometers along with a road of about 10 kilometers. Due to topography of the area at the project location, grading of area had to be done to establish construction facilities. All temporary facilities are located at either end of the bridge. About 50,000 square meters of land on Bakkal and Kauri end was acquired for establishing the site facilities such as fabrication yards, site office, colonies for staff and workmen, batching plants, material stacking, stores, etc. A private telephone exchange with satellite communication facilities is also installed at the bridge site. The bridge would have the total length of 1.315 kilometers from abutment P10 at Bakkal end to P180 at Kauri end, having a total of 17 spans. The deck width would be 13.5 meters at the Kauri end and 17 meters at the arch portion till the Bakkal end. The construction of bridge mainly consists of three parts, consisting of approach span of 185 meters from location P10 to P40 from the buckle end, approach span of 650 meters from location P180 to P50 from the cowrie end, and the main steel arch span between location P40 and P50. The bridge would have a total of 18 foundations with 2 for arch, 2 for abutments, and 14 for the piers. A total of 46,000 cubic meters concrete quantity would be used, along with 3,600 metric tons of reinforcement steel and 25,000 metric tons of structural steel. Excavation of 11,80,000 cubic meters with 57,000 running meters of rock anchoring, drilling would be required to accomplish this specialized task. The entire bridge segment is positioned from location P10 at buckle end to location P180 at the cowrie end. For the purpose of construction of the bridge, both open and pile foundations are being done. Piling work is carried out by conventional methods using tripod along with chisels and balers. Board cast in situ piles of 1 meter diameter are being constructed at locations P150 to location P180. The total number of piles is 109 and the maximum depth of the pile is 35 meters at position P180. Pile caps with a maximum size of 17.6 meters by 11.6 meters and a maximum depth of 4.1 meters are resting on the piles. 12 numbers open foundations for the piers and abutments are laid at 10 meters below original ground level with a depth of 3 meters at location P10 to P30 and locations P60 to P140. Maximum size of foundation would be 17.5 meters by 11.5 meters at location P80. The entire excavation is done using excavators and hard rock blasting. Open foundations for the arch segments would be constructed at locations P40 and P50 with a size of 38 by 28 meters, having a height of 22 meters. L&T Doka shuttering is being used at both these locations. A total of 2 concrete abutments, 5 steel piers and 11 concrete piers are constructed to carry the bridge, besides 9 trestles to support the main arch segment. Concrete abutments would be at the end locations P10 and P180 at buckle and cowrie ends respectively. Locations P20 to P40 from the buckle end and locations P60 to P50 at the cowrie end would have steel piers, whereas the rest of the bridge, that is, locations P170 to 70 from the cowrie end, would be having concrete piers. Concrete piers being used are rectangular hollow type, having a size of 8 meters by 3.5 meters with a wall thickness of 0.5 to 0.9 meters. The maximum height of the concrete pier would be 50 meters at location P140. Slip-form type shuttering is used to build up all the concrete piers from the cowrie end of the bridge. 2 cable cranes of capacity 20 tons each will be used to transport the steel pier components to their respective locations. Fabrication of 3 steel piers is done at buckle end, whereas for the balance is done at cowrie end yards. There are 4 fabrication yards at the construction site with 2 yards at each respective end of the bridge. Yard 1 is just behind location P180 on the cowrie end and is meant for fabrication of deck segments P180 to P45. The sub-assembly shop is used for plate cutting and edge preparation, welding and non-destructive testing, from where it is transferred to the main assembly shop where segments are assembled and welded. The launching yard takes care of connecting the deck elements by welding, quality control and final launch of the segment after painting and metallizing. Quantity of steel work to be done in this yard is about 7,570 metric tons. Yard 2 is at Surandi, located at a distance of 6 kilometers from the location P180 on the cowrie end. This yard is meant for fabrication of arch segments P50 to P45 and steel piers from P60 to P50. Quantity of steel work to be done in this yard is about 6,360 metric tons. Yard 3, located on buckle end, is meant for fabrication of deck segments P10 to P45. Quantity of steel work to be done in this yard is about 3,570 metric tons. Yard 4 at the buckle end is meant for fabrication of steel piers P20 to P40 and arch and trestle segments from location P40 to P45. Quantity of fabrication to be carried out in this yard is about 7,130 metric tons. The deck segment consists of 2 main girders, 2 cross girders and 6 secondary beams, which are assembled as T-members with web and bottom flanges. The first step is to assemble 2 numbers of main girders. Web plates are assembled on a platform. Joints are welded with submerged arc welding machines. This web assembly is shifted to the fixture for connecting bottom flange plate. Main girder is then welded together by submerged arc welding. Thereafter, 2 cross beams and 6 secondary beams are assembled. Cross beams are assembled as T-beams. Steel plates for the deck are then laid and assembled on platform trolley in inverted arrangement for ease of assembly, and as it is the most suitable for submerged arc welding. 2 cross girders and 2 main girders are then fixed with deck stiffeners to deck plate. Lateral trusses are provided to complete the segment assembly. After completing all welding in this position, the segment is then turned upside down with the help of a 100-ton Goliath crane. After completing welding in this position and inspection and weld testing, the segment is shifted to the launching yard for connecting the segments by welding, sandblasting, painting and metallizing, and launching. The main arch consists of various segments bolted together. The arch is tapered towards the middle for providing lateral stiffness. Each arch segment consists of a main chord which has box sections with infill concrete, and its rectangular section allows for bolted joints connected by stiffened plates. Incremental launching method is being used for erection of deck segments on main approach span from both buckle and cowrie ends. For this purpose, launching yards are established at each end respectively. Incremental launching from cowrie end approach is done in 3 stages owing to 300 meters curved alignment of the bridge. Stage 1 of incremental launching is from location P180 to P130. Stage 2 launching is from location P80 to P130, and Stage 3 launching is from location P70 to P50. Balance portion between P80 and P70 is done in situ. On buckle end, incremental launching is done in a single stage from P10 to P40. A launching yard with the launching equipment is established behind the abutment locations P10 and P180 at the buckle and cowrie ends respectively. Prefabricated deck segments are transported to the launching pad on either side. 3 deck segments are connected together by welding, and a steel launching nose of 27 and 36 meters length respectively is attached in front of the first deck segment. This launching nose guides the deck during launching and also reduces the moments in deck during launching operation, thereby avoiding any kind of damage to the piers and the deck segments. Side guidances are provided for proper alignment of the deck during the launching on this curved portion. A temporary pier is erected between P170 and P180 for load balancing. Pushing the 3 welded segments with launching nose using 2 hydraulic jacks will launch the deck to the extent of a length of 1 segment, that is 25 meters. Before the next launching, another 3 deck segments will be connected and launching would be repeated for another 25 meters. This procedure would be repeated till the deck is launched and placed in correct positions from P180 to P130. A temporary pier is erected between positions P120 and P130. Once the first deck segment reaches this temporary pier, the launching nose is removed using a derrick. Prefabricated deck segments are transported up to location P130 from the cowrie end on a trolley on the bridge deck and lowered using a derrick, and thereafter taken to the launching pad by a 100-ton capacity trailer and lifted with the help of the 100-ton Goliath crane. For stage 2 of launching, a launching yard including 100-ton Goliath crane is established between P70 and P80. A temporary pier is constructed between locations P80 and P90 for load balancing. The process of incremental launching is carried out from the platform at P80. The launching nose is dismantled by using a derrick as the deck segment reaches the location between P130 and P120. Middle segments are joined by bolting, completing the stage 2 of incremental launching from the cowrie end. Stage 3 of incremental launching from P70 to P50 uses the launching yard between P70 and P80. Segments are shifted to the launching yard by the trolley on the deck. It is lowered down onto the platform using the 100-ton Goliath crane. A temporary pier is constructed between locations P70 and P60 to carry out the incremental launching process up to location P50. The balance span between P80 and P70 is erected on the platform itself. The approach from the buckle end being straight, the incremental launching is carried out in a single stage between P10 and P40, following the same process. Two cable cranes with a capacity of 20 tons each and two derrick cranes with a capacity of 100 tons each are used to complete the main arch segment of the bridge between locations P40 and P50. For load balancing, the work of lifting and placing the arch segments followed by deck segments is done from both P40 and P50 ends alternately. A derrick is placed in position P40 and the first two arch segments are lowered and placed in position. Once the arch reaches the trestle position P41, a trestle is erected here. Same is true for location P49, wherein another trestle is erected. Arch segments are followed by deck segment at P40, which are delivered on a trolley, picked up by the derrick, rotated and then lowered before fixing in place. Diagonal support to partial arch at P40 end is given for load balance. The same process is repeated from the P50 end of the arch. A temporary bracing is provided with each trestle being erected. Arch, deck and trestle construction would happen for the rest of the span in similar way from both ends alternately. The tracks are laid on the deck segments with expansion joints at 3 positions to withstand temperature variations. The bridge is one of the most prestigious projects awarded by the Indian Railways and executed by an Indian company. Not to say it is one of its kinds in the world. The world's highest railway bridge by the CBPU has already put India on the world map of superstructures, yet once again.